All right, so here's another think pair share. Once again, attempt this one on your own and resume or watch this video whenever you're ready. So this is about college student anxiety. So Dan's at college is interested in the relationship between anxiety level and the need to succeed in school. A random sample of 400 students took a test that measured anxiety level and need to succeed in school. The following table shows the results. De Anza College wants to know if anxiety level and need to succeed in school are independent events. So anxiety level, that's one random variable, and need to succeed in school are your second random variable. And we want to see if those are independent events. So this table represents our observed values. All right, so let's look maybe at our givens. And once again, confidence level is not given. So we can assume that we've got a 95% confidence level, okay, which implies we've got a significance level of 0.05. Okay, degrees of freedom. That's equal to the number of rows minus 1 times the number of columns minus 1. So the number of rows we have is 1, 2, 3. And then the number of columns, 1, 2, 3, 4, 5. So that's going to be 2. 3 times 1 is 2, and then 5 minus 1 is 4. So 8. So we have 8 degrees of freedom. All right. So I think that's all we're going to get for step 1 as far as our given information. Let me try, operative word is try to scroll down. There we go. And so now it's going to be step 2. So this is going to be to set up our null and alternate hypotheses. So the null hypothesis is that anxiety and need to succeed are independent. Okay, and that is our original claim. And the null hypothesis is that anxiety and need to succeed are dependent. Okay. So now step 3 is to calculate our chi-squared test statistic and our p-value. Okay, and this comes from our sample data. All right. So on the Texas Instruments calculator, this is where you need to enter in the table of data in a matrix. And you can see here under the edit menu, matrix A, I've already entered the information, okay, as a 3-row by 5-column matrix. So a 3 by 5 matrix has the dimensions 3 by 5. And don't forget, the matrix that you are going to be putting the expected values into has to have the same dimensions as your observed data matrix. So right now, this is going to throw me an error if I try to do a chi-squared test. So I need to be in the edit menu. I need to choose matrix B and have to change it to a 3 by 5. So I'm just going to cursor over here to that, change that to a 5 and hit enter. So you can see it added a couple more columns, and that's all I got to do. It'll overwrite these values with my new expected values. Okay, so I'm just going to quit, get me out of that. With the NumWorks calculator, I just need to go to the Inference app, go to Tests, chi-squared, homogeneity and independence. And I went ahead and entered the values in here. So you can see I've got a 3x5 matrix, 5% significance level. Click Next. Okay, it's giving me all of the expected values. Click Next. And here's my chi-squared statistic as well as my p-value. And the p-value is really small, right? This means 10 to the minus 8. So the decimal place is going to go to the left 8 spaces. So I'll have 7 zeros ahead of this. But let's do the same thing here on the Texas Instruments. We should get those same values. So stat, tests, I'm going to move up one. Chi-square test is closer to the bottom. Click enter. Okay, matrix A was my matrix of observed values. Matrix B is going to be my matrix of expected values. They both have the same dimension. So I hit calculate. And 48.42 and 8.2 times 10 to the minus 8. So that's a decimal point with 7 zeros and then 8.2. That's a really small p-value. All right, so let's go ahead and write those values down. So my chi-squared test statistic is 48.42. And my p-value was 8.2 times 10 to the minus 8. Really, really small number. Oh my goodness. There we go. Let's keep going down. All right, so let me go ahead and write these values down. All right, so step 4 is we're going to sketch our distribution. And it's right-tailed. It looks something like that. And yes, right-tailed. So there's our chi-squared critical value. The area over the tail, the region over the tail, is the reject the null. Over the confidence level, that's fail to reject. This area adjacent to the critical value, that's our significance level. And now let's calculate our critical value. I'm going to switch to green here. There we go. All right, so let's use one of our inverse chi-squared functions. So program inverse chi-squared 0.05. Oops, didn't put in the point. And we have 8 degrees of freedom. So 15.51. Okay, NumWorks. Let's just do that for completeness. So we want to go to the distributions app, chi-squared, 8 degrees of freedom, area to the right, 0.05, 15.51. Okay, good. Okay, our test statistic is 48.42, which is clear off to the side. So that is our test statistic, 48.42, which when you go straight up, clearly indicates we're going to reject the null. The p-value is a really super small number, 8.2 times 10 to the negative 8, right? And if p is smaller, reject the null. So now we can move on to our last and final step, step 5, which is to put our results together and write a conclusion. Okay, so step 5. Results and conclusion. Um, so in the end, we determined we're going to reject the null, and the null was our original claim. So rejecting the null, null is the original claim. There we go. There is sufficient evidence to support rejection of the claim that give me green. There we go. Anxiety and need to succeed are independent with a 95% confidence level. Okay, and we are done. Let me know if you have any questions.